Question 7 asks us to complete the square, and so completing the square with a 2 in it, we haven't had one of those for a while. Lots of the earlier exam papers just had x squareds, but if you've got a 2 there first, then we've got to take out the factor of the 2. So this thing here and this thing here are both exactly the same. Now this x squared, half of 10 is 5, but don't forget to take away the 25 there. That bracket is that whole thing there. We're still timesing it by 2. One more line then, multiply that by 2. We've got minus 50 here, plus the 53, means we've got a plus 3 on the end. There's our final answer. Really nice question here about explain why this is no real roots. The fact that it says use this answer means that we can't go down a b squared minus 4ac route, because that wouldn't be using this answer. A few things we could do for this. I've seen a few people do it just using some algebra. So they say, well, this thing here is going to equal 0. So they take away 3 and then divide by 2. So take away 3 and divide by 2. And then you say, well, we cannot square root minus 3 over 2. Therefore, no solutions or no roots. Perhaps a nicer way of doing it would be to think about what the graph of this thing looks like. And the graph of this thing, it's going to have a minimum point at 5, 3. It's going to be crossing at 53 up there, isn't it? So it looks like this. So we're going to say, therefore, never touches x-axis, never equals 0, so therefore no roots. I think either approach is valid as long as you finish off with some sort of statement. Moving on to part B, we have got our b squared minus 4ac parts, and what are we looking for? We're looking for the real roots. So a statement to start, say what we're doing. For real roots, b squared minus 4ac, what do we want? Real, so it's going to be greater than or equal to 0. Got to be positive or equal to 0. So what is b? B's that bit there, k plus 1 squared minus 4 times a, which is that thing there, times by c, which is that, and we want that greater than or equal to 0. Some algebra to play with, multiply out that bracket, and what we're doing here, we've got minus 4 times 2 times, that's 8, and then we've got a k squared there, and be careful, we've got the minus minus here, 4 times 1 times k is 4k. Is this going to tidy up to give what we want? I'm not quite. K take away 8k is minus 7k squareds. I've got a 2 and another 4, making 6k's, and we've got a plus 1 greater than or equal to 0. Not quite what they were looking for. Let's add it all to the other side then. So if we add the 7k squareds, let's take those k's off. Let's take off the 1, and that's now 0. Now we've got exactly what they were looking for. Hence, find the possible values of k. Let's look at that quadratic we were looking at here. Let's put it equal to 0. Let's find out where it equals 0 first. Got to factorise. It's not going to be difficult to factorise because with a 1 here, it's got to be 1 and 1. Just got to get your signs around the right way. That minus would give minus 7 plus the 1. So we've got 2 values when it equals it. Minus a 7th and equal to 1. And you've got to draw this sketch or do a sign diagram or something so you actually know which bit we've got. So there's the minus 7th, there's the positive 1, and the graph's looking like this. You can even check that, look, it's crossing at minus 1 there. We want that to be lower than 0. So I colour in my bit there. That's the bit that we want, lower than 0, so that's when minus 7th is less than or equal to k, is less than or equal to 1, and that's the end of it.